Every year, India awaits the rains like clockwork. The monsoon, more than just a weather event, is the pulse of a billion lives. But now the pulse is irregular. The rhythm is faltering. From erratic rainfall to unexpected storms, a new climate reality is knocking on India's door. Namaskar and welcome to Sansad TV. I'm RAJIV Singh. The monsoon season is here, and so are a number of questions and theories. Would it be a normal monsoon year? Which part of the country will receive above normal rain? Or which areas would be rain deficient? Are there any climatic conditions related to the monsoon India needs to worry about? All these and much more in this episode of History Behind Headlines. Monsoon, Clouds of Change. The word monsoon comes from the Arabic Monsoon, meaning season. In India, it is much more than that. It is a cultural and agricultural cornerstone. India's southwest monsoon typically arrives in Kerala by June 1st and gradually progresses northward, covering the entire country by mid-July. For centuries, this 4-month spell, June to September, has dictated the economic fate of the nation. Nearly 50% of India's farmland depends entirely on monsoon rains. Over 70% of annual rainfall happens during this time. From rice paddies in Bengal to cotton fields in Maharashtra, monsoon rains bring prosperity, or in their absence, devastation. India's obsession with monsoon patterns is not new. Indians had a long history of observing and using monsoon winds for navigation and trade, predating the commonly attributed discovery by Greek mariner Hippalus. Archaeological evidence and literary sources indicate that Indus Valley civilization, as early as 2500 BCE, was using monsoon winds and currents for maritime activities. Additionally, the Rig Veda, composed around 1500 BCE, mentions the peculiarities of the monsoon. The Vedic texts, particularly the Rig Veda, have mention of hymns that praise Indra, the god of rain and thunderstorms, for his role in bringing life-giving rains to the earth. Rain rituals and sacrifices were performed to appease Indra and ensure a bountiful harvest, signifying the deep spiritual and cultural significance of the monsoon in early Vedic life. Kautilya's Arthashastra contains records of scientific measurements of rainfall and its application to the country's revenue and relief work. Kalidasa, in his epic Meghdut, written around the 7th century, even mentions the date of onset of the monsoon over central India and traces the path of the monsoon clouds. Reading of the monsoon pattern began in earnest during British rule, when famines due to monsoon failures ravaged large parts of the country. In 1875, the Indian Meteorological Department, IMD, was set up to systematically monitor the weather phenomena. Using barometers, rain gauges, and wind charts, the monsoon was observed with scientific rigor.
Over the 150 years, IMD has made tremendous progress in all this component of your weather forecasting services, and now we have also reached to different sectors. now agriculture sector, power sector, hydrological sector, health sector, tourism sectors. So all these sectors now they need the weather weather and climate prediction, and even the climate extreme data, even the normal data. So all these things are that means that 150 years IMD has progressed a lot in all these components in providing the weather and forecasting services to various users.
Over the decades, prediction models improved from statistical to dynamic models, satellites, and Doppler radars. Yet, in recent years, these forecasts have grown less reliable, not because of technological failure, but because the monsoon itself has become unpredictable. Monsoon is a complex meteorological phenomena, which even the meteorologists are yet to fully explain. There are a number of theories for its formation. The most accepted is that land heats up faster and cools down faster than water due to its lower heat capacity. During summer, the land becomes much warmer than the surrounding sea. The warmer land creates a low pressure area, while the cooler ocean maintains a higher pressure. Air flows from areas of high pressure towards areas of low pressure, resulting in monsoon winds. As the wind blows from the ocean to the land, they carry moisture, which leads to heavy rainfall during the monsoon season. Other theories provided are shifting of the intertropical convergence zone, ITCZ, which is a low pressure belt near the equator, where the northern trade winds and southern trade winds converge. During the months of June and July, the ITCZ shifts towards the north near the Tibetan Plateau, making the monsoon winds stronger. The third reason for monsoon formation is the heating up of the Tibetan Plateau during the months of March to June, creating a low pressure zone, resulting in the winds from the Indian Ocean laden with water vapor rush towards the Tibetan Plateau. As the southwest monsoon winds travel over land, they cool down and result in rain over the Indian subcontinent. Another theory related to monsoon winds formation over the Indian subcontinent is the jet stream theory. Jet streams are high-altitude, fast-flowing air currents in the upper troposphere at around 8 to 15 km altitude. The two main jet streams that influence the Indian monsoon are subtropical westerly jet stream and tropical easterly jet stream. Key points about jet streams and monsoon to remember are that the position and strength of jet streams directly affect the timing and intensity of monsoon rains. A strong and well-positioned tropical easterly jet stream enhances monsoon activity. Blocking of subtropical westerly jet stream allows the northward migration of monsoonal winds. Breaks in monsoon are also related to fluctuations in jet streams. Historically, the Indian monsoon had a fairly predictable pattern, but over the last 2 decades, scientists have recorded worrying changes.
Climate change has significantly altered the pattern, intensity, and distribution of Indian monsoon. And because of this, it is making it increasingly unpredictable, we will say. We will not say that it is simply reducing the rainfall overall. So, and when we are adding this word unpredictable, means the extremities related to monsoons are happening, which may be floods. One extreme is flood situation, another extreme is the drought situation. And this volatility in the monsoon is exactly what the climate scientist and IPCC reports has predicted and warned about decades ago. So I will say that now India must prepare not just for water scarcity issue, but for also managing too much water in a very short time, specifically for a vulnerable regions.
A decline in the number of rainy days, but an increase in rainfall intensity frequent pre-monsoon rainfall and delayed withdrawals, rising temperatures even during the monsoon season, increased frequency of extreme events, flash floods, droughts, and heat waves coexisting in the same region. The IMD's 2023 report warned of a 6% deficit in seasonal rainfall, but with an uneven distribution. Some areas saw excess rainfall, others saw complete failure. According to IMD's forecast for 2025, the seasonal rainfall across the country as a whole is likely to be 106% of the long period average, with a model error of plus to minus 4%, indicating a high probability of above normal rainfall during the monsoon season. Regionally, the rainfall is most likely to be above normal over central India and the South Peninsular region, while northwest India is expected to experience normal rainfall levels ranging between 92 to 108% of the LPA. In contrast, northeast India is likely to receive below normal rainfall, that is, less than 94% of the LPA. The monsoon core zone, which covers much of India's rain-fed agricultural land, is also forecast to receive above normal rainfall, providing a favorable outlook of the Kharif cropping season.
The climate models, when any numerical model, when we are talking about the monsoon prediction, all the numerical model, so over the year it has improved a lot compared to, let us say, 30 years before this thing. Because now the more and more data are coming, observation data are coming, satellite data are coming, we have a good estimation technique, so which is required for the model to start. Then we have assimilation, then physical process. So over the year, actually monsoon models prediction have improved. But your question with respect to this localized rainfall prediction. So specific to the localized rainfall prediction, yes, that is a very greatest challenging part. But because the climate change, due to the climate change, the frequency of this extreme heavy rainfall event like the just what we are witnessing nowadays during the monsoon season, so that frequency have increased. So that has given a challenge to the model. But with respect to numerical model or climate model, what we are using for the prediction, that has improved a lot.
How do we know this is climate change? The evidence is actually mounting. A study by the Indian Institute of Tropical Meteorology confirms that the warming of the Indian Ocean, now 1 degree centigrade warmer than pre-industrial levels, is directly disrupting monsoon circulation. Increased greenhouse gas emissions have altered the land-ocean thermal gradient. The Bay of Bengal and Arabian Sea are both seeing more cyclonic activity, impacting monsoon onset and withdrawal.
The climate change is definitely a fact, and now we are witnessing this thing. Our observation data is also showing climate change. As a result of climate change, what is happening with respect to your monsoon or the extreme weather? So definitely there is some changes in the pattern of monsoon, but fortunately, if we see our instrumental record, the rainfall data, seasonal monsoon rainfall that is available from 1871 till now, if we see, there is not long-term trend is not there. That means either decreasing or increasing trend is not there with respect to country as a whole. When you categorize the rainfall, then what you categorize means based on the 24-hour accumulated rainfall in any station. So when you categorize this rainfall, the total rainfall, not much significant trend is there, but there is a significant increasing trend with respect to the frequency of heavy, very heavy or extremely heavy rainfall. So these frequency are more and the moderate, light moderate frequency are less. So as a result, what is happening during the entire monsoon season, let us say 122 days, June to September, so you may get very less number of rainy days, but with respect to heavy or very extremely heavy rainfall.
In May this year, as well as the first week of June, India has experienced a climatic anomaly. a period usually synonymous with scorching heat, saw record rainfall in central and northern states. Delhi, Lucknow, Jaipur all witnessed untimely squalls, thunderstorms and rain. Dust storms disrupted flights. Schools shut down in parts of Rajasthan. Farmers were caught off guard too. What caused such erratic weather? A combination of elevated sea surface temperatures in the Arabian Sea and western disturbances moving further south due to jet stream distortions, both linked to climate change.
We are observing the shifting in pattern and extremities. For example, in Delhi NCR regions only, in between 15th May to 5 June 2024, Delhi has experienced over 14 major thunderstorms and square events. And as compared to which this events number were 4 to 6 events only a decade ago. And recently, we have also observed that wind speed has reached around 80 km/h in recent squares, which is classified as a severe and which disrupted not only the airlines cancelled, but power lines also. They have uprooted the trees and different problems have, even the death from some reason have also reported. Similarly, in states like Sikkim, Himachal Pradesh and Uttarakhand, they have witnessed landslides and flash floods in May 2024, which is before the monsoon. During the monsoon, we used to hear that, okay, landslide happened, but that the interesting thing on unpredictability is that it reported before the monsoon onset. And it's also triggered the sudden cloudburst and unseasonal rainfall. IMD reported that pre-monsoon rainfall in Himachal Pradesh was 68% above normal in 2023 and 54% above normal in 2024. So this is saying that patterns are also shifting and extremities related to monsoon are also reported from a wide area.
The changing monsoon isn't just a meteorological concern. It is an agricultural crisis. Small and marginal farmers, who comprise over 85% of India's farming community, rely on timely rains. Crop calendars are thrown into disarray, pest infestations rise, and yields drop. Rice, wheat, pulses, sugarcane, India's staples are now vulnerable to climatic shocks. Though paddy output in India has been constantly on the rise over the last 5 years, in 2022, wheat output fell by 5 million tons due to a heat wave post-unseasonal rains. India's food security, rural economy, and inflation management are now hostage to a volatile sky. What can India do? Short-term solutions include improving early warning systems, crop insurance penetration, and real-time advisory to farmers. Long-term strategies demand diversification of crops away from water-intensive varieties, investment in climate-resilient infrastructure, better rainwater harvesting and groundwater recharge, regional cooperation on weather forecasting. The Indian Meteorological Department has recently made a leap with Made in India Bharat Forecast System, which promises more accurate predictions. To improve rainfall forecasting, the Ministry of Earth Sciences has set a target to develop next-generation indigenous weather forecasting systems under the Atmanirbhar Bharat initiative. Under this directive, the Indian Institute of Tropical Meteorology, IITM, which functions under the Ministry of Earth Sciences, has developed state-of-the-art models for short and medium range, extended range, and seasonal forecasts. India's current short and medium range forecasting system is a global ensemble system with 20 members and a resolution of 12 kilometers. As extreme weather events increase, so does the demand for better accuracy. To address this need, IITM has developed the Bharat Forecast System based on the TCO, or Triangular Cubic Octahedral Grid, which offers a high-resolution output of 6 kilometers, a significant improvement over the earlier 12-kilometer resolution. This achievement marks an important step in the development of indigenous weather and climate models. Implemented in 2022 and tested over the last 3 years, this model has shown a 30% improvement in forecasting heavy rainfall events and a 64% improvement in predictions over the monsoon core zone. The Bharat Forecast System is now fully ready for real-time operational use. With this historic achievement, India has become the only country in the world operating a global forecast model at a 6-kilometer resolution. This system is dedicated to providing not only Indian citizens but also the global community with high-resolution, accurate and reliable weather forecasts.
If you look at the science of meteorology, it is directly related with the services to the people, to the community, and hence the socio-economic activity, not only our country, but also the entire world, and especially this region. This development is not limited only to the Indian region. It is entire tropical region will be benefited by this model. And hence, in the line of Vasudhaiva Kutumbakam, this development will also help to each and every one.
India's National Innovation on Climate Resilient Agriculture, NICRA, has launched initiatives, but scaling up remains a challenge. Indian farmers getting SMS alerts about rain is fine. Going forward, what it really needs is a system to minimize damage and support after damage is done.
There is a need that we should strengthen our urban infrastructure, which is in a struggling stage, to keep up with this unpredictability, as well as in hail and flood-prone regions which are facing more frequent disasters even before peak monsoons. For them also, we need a policy as well as adaptation measures to overcome that, and agriculture, which we know that in India's GDP, the contribution of agriculture sector is very high, and especially the rain-fed farming systems, which are dependent upon rain. So their productivity is also under threat due to this unpredictable behavior of Indian monsoon. So with all these attributes, I think we need policy measures to prevent the negative impact of the unpredictable Indian monsoon, as well as to increase the adaptation capacity of those who are vulnerable to this.
So, what does the future hold? According to the Intergovernmental Panel on Climate Change, IPCC, India will face a more erratic monsoon with each passing decade unless global emissions are curbed. If current trends continue, heat waves will triple by 2050. Monsoon rainfall will become even more uneven. The number of extreme rain events could double. India must therefore lead in climate adaptation, not just because of its vulnerability, but because of its example. With over 1 billion people dependent on monsoons, the world is watching. The monsoon was once predictable, poetic and dependable. Today, it is a warning signal, a barometer of world out of balance. Climate change is no longer about rising seas and melting glaciers far away. It is here, in the falling rain, in India's skies, in its soil. To ignore the changing monsoon is to endanger the heart of India. That is all we have in this program. Thanks for watching.